Hello and welcome to today's lesson on the IV characteristics of a filament bulb, which is part of the electricity topic in GCSE Combined Science Physics. So in today's lesson we're going to look at drawing a current potential difference graph for a filament bulb. So if we've been successful and learned in today's lesson, you should be able to understand how to take current and potential difference readings over a filament bulb, draw a current potential difference graph of a filament bulb, and then analyze the data taken from the current potential difference graph of a filament bulb, which leads into the following part of the GCSE Combined Science Physics specification. Now in this topic we're looking at the concepts of electrical circuits and how they operate. Now to understand this we've got to measure values in the electrical circuit, and the most common values to measure in an electrical circuit are current and potential difference. Now current is the rate of flow of electrons in the circuit, and potential difference is the work done per charge by the device. Now we measure the current with an ammeter and the potential difference with the voltmeter. Now it's important to note that therefore current is measured with an ammeter placed in a series circuit, whilst potential difference is measured with the voltmeter placed in parallel with the device measured. Now to gain accurate and reliable values we've got to take many values of current and potential difference, as this allows us to graph the experimental results. Now graphs give us more accurate and valid conclusions as they allow trends to be drawn and anomalies to be spotted in the results. Now to do this, a variable resistor is used to change the values of current and potential difference to give many results with a wide range. So here is a circuit diagram of the electrical circuit needed to produce an IV graph. Now the only device that may change in this circuit is the device being measured. It could be a filament bulb, it could be a resistor, it could be a wire, it could be a diode. Now remember, the voltmeter goes in parallel with the device being measured, whilst you've got to include a variable resistor, as this will give you many values in the investigation to draw a graph from. Now in this particular investigation we're going to look at the current potential difference graph of a filament lamp, which is a common type of light bulb because it contains a thin coil of wire called a filament. Now this heats up when a current passes through it and produces light as a result. Now you'll notice from our current potential difference graph that the filament lamp does not follow Ohm's law because it's a curving line and not a straight line. So when the potential difference across the bulb increases, the temperature of the bulb will also increase. This means that the metal ions will vibrate further and collide with more electrons, and this increases the resistance of the circuit. Now remember, the gradient and the resistance are inversely linked, so you'll notice that the line becomes flatter as your potential difference increases. This is because it's more difficult for the electrons to flow through the wire, so the line starts to become flatter. It has a higher resistance, so the resistance of any metal increases as its temperature increases. Now like we mentioned before, a filament lamp does not follow Ohm's law, but reversing the potential difference reverses the current and makes no difference to the shape of the curve. The resistance is the same for the same current regardless of direction. So just to clarify, this is the current potential difference graph for a filament lamp. Now you'll notice that in the middle here the bulb is cooler because there's less potential difference, so there's less resistance, while when you increase the potential difference either positively or negatively, the bulb becomes hotter, so there's more resistance. Now you'll notice that the bulb has a constant resistance of low values of PD, so at this point it's obeying Ohm's law because it's shown as a straight line. This is because at low values of potential difference the temperature of the coil is constant. Now a bulb can actually break as the resistance is so low when the bulb is off that a big current passes through it when you switch it on, and so if the current is too big it can burn out the filament. Now in this particular investigation we're going to look at the relationship between current and potential difference for a circuit containing a bulb. So the aim of this particular practical is to draw the IV graph for a filament bulb. So in this investigation you will require a filament lamp, a power pack, wires, ammeter, voltmeter and rheostat. So what you would do is you set up the following circuit and connect the ammeter and the filament bulb in series with the rheostat and the power supply. You switch off the supply or disconnect the filament bulb when not making the measurement, and you connect the voltmeter in parallel with the filament bulb. You would then switch on the circuit, quickly note the ammeter and voltmeter readings and switch off for a few seconds. You would then lower the potential difference using the rheostat and switch on again to take the new set of readings. Now don't worry about setting the voltage to a particular value, you just aim to get 10 readings fairly evenly spaced between 10 volts and 0 volts. You then repeat the experiment again, however this time you reverse the leads on the battery connections. This will give a negative potential difference in current values, so you switch on the circuit, quickly note the ammeter reading and the voltmeter reading and switch off for a few seconds. You then lower the potential difference value slightly using the rheostat, switch on again to take the new set of readings, and once again don't worry about getting a particular value of potential difference or voltage, you just aim to get 10 readings fairly evenly spaced between -10 and 0 volts. So you would retrieve a 10 volt light bulb which will have a 12 volt label on it and has a working filament. You would get a power pack set to 12 volts and ensure the power pack is set to DC. You get an ammeter and a voltmeter, checking that both meters are working and have no loose connections. The ammeter will measure the current in the circuit and has no resistance. The voltmeter will measure the potential difference in the circuit and it has an infinite resistance. You will also retrieve a rheostat, which is the correct name for a 3-connector variable resistor. Now the rheostat is used to alter the values of current and potential difference, as this will allow you to plot a graph of current and potential difference. So you'd set up the series circuit with the power pack, ammeter, light bulb and rheostat in a series circuit. You'd connect the ammeter in the circuit as a series component, and you would connect the rheostat correctly using one lead that goes into the top connector and the other lead that goes into the bottom connector. Now if a device is reading a negative number, it indicates to us you've connected the wires the wrong way round. Now a voltmeter should then be placed in parallel with the device being measured, which in this case is the filament bulb. So what you would then do is you'd measure the current and the potential difference 10 times for positive values. Now the values are varied by moving the rheostat slider, and you may choose your own values for current and potential difference. So for the 10 values, try to get a large range for the potential difference, as this will give you a better graph to draw. Now remember, the larger the range of data, the better the trend shown, and also to remember to switch off the power pack between the readings, otherwise the results may be affected. What you would then do is you would reverse the leads and measure the current and potential difference 10 times for the negative values. This means you're taking the negative values, so therefore your axes of your graph will need to include these negative numbers. So you'll need to think about what type of graph you would draw. So you then fill in the results table as follows, with current measured in amps and potential difference measured in volts. You then plot a graph of current on the y-axis and potential difference on the x-axis, including both a positive and negative axes to your graph, so it looks something like so. Now here you can see a set of sample investigative results. A few things to note: that all the values have been given to the same number of decimal places, and the number of decimal places recorded is given by the resolution of the measuring device. So our voltmeter and our ammeter can read to 2 decimal places, so our values are given to 2 decimal places. Now here is a sample graph of the experimental results. Now we'll notice that the axes have been labelled with units and the points have been correctly plotted, and the graph is drawn with a scale to give a large variation in the data. Now a line of best fit is being drawn through both the positive and negative sections of the data. Now what conclusion can we make from this? That this does not show direct proportion, since the graph does not produce a straight line through the origin. So this tells us that this component, a filament lamp, does not follow Ohm's law. So let's just summarize what we've learned in today's lesson. The resistance of components such as lamps, diodes, themistors and LDRs are not constant. It changes with the current through the component. Now the resistance of a filament lamp increases as the temperature of the filament increases, with the following graph showing you what a graph of a filament lamp would look like. Now if you've been successful and learned in today's lesson, you should be able to take current and potential difference readings over a filament bulb. You should be able to draw a current potential difference graph of a filament bulb, and finally analyze the data taken from the current potential difference graph of a filament bulb. So I hope you've enjoyed today's lesson, where we've looked at the IV characteristics of a filament bulb, which is part of the electricity topic in GCSE Combined Science Physics. Thank you very much for watching today's lesson, and as always, have a lovely day.